Welcome to Restitution Sanstha Satara, the Rayat Online School Education Project. We have already started with the topic laws of motion, and today we shall learn about elastic and inelastic collisions, coefficient of restitution, head-on collision, non-head-on collision, and loss in the kinetic energy during perfectly inelastic head-on collisions. We understand what is collision, right? During collision, a number of objects come together, interact, that is, exert forces on each other and scatter in different directions. During a collision, the linear momentum of the entire system of particles is always conserved, as there is no external force acting on the system of particles. See, the question is of linear momentum. Sir, external force act होत नसेल, the linear momentum is conserved, of the system is conserved. This is according to Newton's second law of motion. ही गोष्ट झाली linear momentum. Now there are two types of collisions depending upon whether kinetic energy is conserved or not. The first is elastic collision. See, in elastic collision, kinetic energy of the entire system is conserved. Linear momentum is also conserved and kinetic energy is also conserved. And in inelastic collision, linear momentum is conserved, but kinetic energy is not conserved. In inelastic collision, there is always a loss of kinetic energy. So, in inelastic collision, the loss in kinetic energy is either due to internal friction or vibrational motion of atoms causing heating effect. So, in inelastic collision, initial kinetic energy is always greater than final kinetic energy. Momentum, linear momentum in both cases, in inelastic and inelastic collision, is always conserved if there is no external force acting on the system. And in inelastic collision, initial kinetic energy is greater than final kinetic energy. There is loss of kinetic energy. We shall now see what is perfectly inelastic collision. If colliding bodies join together after collision, it is said to be perfectly inelastic collision. The colliding bodies have a common final velocity after perfectly inelastic collision. म्हणजे जर दोन बॉडीज कोलिजन नंतर जर एकत्र राहिल्या तर एकच बॉडी म्हणून जर पुढे मूव्ह झाल्या किंवा जागेवर राहिल्या तर then it will be perfectly inelastic collision. In perfectly inelastic collision, the loss of kinetic energy is maximum. We shall consider it through an illustration. Consider a bullet fired towards a block kept on a smooth surface. Collision between the bullet and the block will be elastic if the bullet rebounds with exactly same initial speed and block remains stationary. असं आहे, समजा हा एक ब्लॉक आहे and a bullet which is kept on some say surface table or table. Suppose a bullet is fired. He bullet fire झाल्यावर त्याच्या suppose it rebounds with the same velocity in the same direction, so in the exactly opposite direction, म्हणजे अशी with the same initial velocity, त्याची जी u velocity या डिरेक्शन मध्ये होती, आता पण यूच वेलोसिटी फक्त एक्झॅक्टली अपोजिट डिरेक्शन मध्ये जर असेल असं जे कोलिजन आणि ब्लॉक जो स्टेशनरी होता तो स्टेशनरीच आहे, असं जे कोलिजन असेल ते झालं परफेक्टली इलास्टिक कोलिजन. परफेक्टली इलास्टिक कोलिजन. इलास्टिक कोलिजन हे परफेक्टली इलास्टिकच असतं. त्याच्यात परफेक्टली आणि पार्शियली आणि 100% इलास्टिक वगैरे असं काही नाही. हे झालं परफेक्टली इलास्टिक म्हणजे इलास्टिक कोलिजन. इट इज ऑलवेज परफेक्टली इलास्टिक कोलिजन. But if the bullet gets embedded into block and the two move jointly, it is perfectly inelastic collision. जर बुलेट ब्लॉक मध्ये आतमध्ये घुसली आणि नंतर both they move jointly, it will be a perfectly inelastic collision. If the bullet rebounds with smaller speed or comes out of the block on the other side with some speed, it will be partially inelastic collision. Partially inelastic collision. Elastic collision मध्ये perfectly इलास्टिकच असतं आणि inelastic collision can be partially or perfectly inelastic. आणि perfectly inelastic collision मध्ये both the bodies join together and move with a common velocity. We can have one more example of collision. Suppose I have got a hard surface. म्हणजे हा suppose एक ball घेतला आणि it is dropped. समजा तो बॉल परत रिबाउंड होऊन परत त्याच हाईटला तितक्याच हाईटला जर आला एक्झॅक्टली उलट्या दिशेने तर देन इट विल बी इलास्टिक कोलिजन. जे जनरली आपलं ऑब्झर्वेशन नाही. सपोज द बॉल कम्स टू सम अदर हाईट, तो दुसऱ्या कुठल्या हाईटला आला म्हणजे इट विल बी लेस दॅन द इनिशियल हाईट, राईट. तर ते पार्शियली इनइलास्टिक कोलिजन असेल, इनइलास्टिक, बट इट विल बी पार्शियली इनइलास्टिक कोलिजन. आणि समजा बॉलच्या जागी आपण मड किंवा क्ले घेतलं, व्हॉट विल हॅपन इज आफ्टर द कोलिजन द मड किंवा क्ले तिथे चिकटून बसेल. दिस विल बी perfectly inelastic collision. We shall now see what is coefficient of restitution. Consider a one-dimensional head-on collision. Head-on collision is the collision where the colliding bodies move along the same straight line before and after collision. See, we have got a body of mass m1. It is moving with velocity u1. We have got body of mass m2. It is moving with velocity u2. This is the situation before collision. During the collision, each mass experiences a force. That is, mass m1 experiences a force f1. 2. That is, mass m1 experiences force due to collision with m2. So the force experienced by body 1 due to 2 is F12. Force experienced by body 2 due to 1 will be F21. This is the notation used. After collision, the body of mass m1 moves with velocity v1 and the body of mass m2 moves with velocity v2. Now, as it is head-on collision, all the bodies are moving along the same straight line. So the vector treatment at present is not essential. Now, before collision, the relative velocity of approach is u2 minus u1, and after collision, relative velocity of separation is v2 minus v1. So coefficient of restitution is defined as negative of velocity of separation to velocity of approach. In perfectly inelastic collision, both bodies stick together after collision, right? Perfectly inelastic collision. They both bodies stick together. What will be relative velocity of separation? दोन्ही bodies stick together होतात. They move together with the same velocity. So relative velocity of separation is 0 for perfectly inelastic collision. So as the numerator is 0, coefficient of restitution is 0 for perfectly inelastic collision. Just now we have calculated coefficient of restitution for perfectly inelastic collision. आता जर हीच situation suppose perfectly elastic collision असेल हे, तर वहाँ will calculate the coefficient of restitution. Let us see now. See now, we'll apply law of conservation of linear momentum. So initial linear momentum before collision, m1 u1 plus m2 u2 will be equal to final linear momentum after collision. Final velocity is v1 v2h, so m1 v1 plus m2 v2. So he term, I need a notation. This term m1 v1, suppose it is taken to this side. So m1 u1 minus m1 v1 will be equal to m2 v2 minus m2 u2. आणि मग m1 कॉमन काढलं की m1 u1 minus v1 will be equal to m2 v2 minus u2. Now it is आपण perfectly elastic collision consider करतोय. So kinetic energy is also conserved. So kinetic energy before collision is half m1 u1 square plus half m2 u2 square will be equal to kinetic energy, total kinetic energy after collision, which will be half m1 v1 square पहिल्या बॉडीची आणि दुसऱ्या बॉडीची plus half m2 v2 square. What we shall do is this see now, see. This half will come common and will get cancelled. So I shall show it cancelled like this. This term m1 v1 square, when we'll go to left side, will become negative, and this when we'll go to right side will become negative. Okay, so m1 u1 square minus m1 v1 square will be equal to m2 v2 square minus m2 u2 square. Now we'll take m1 common, and u1 square minus v1 square will be factorized as u1 minus v1, u1 plus v1. So it is like this. m1 taken common, u1 minus v1 and u1 plus v1. Here it will be m2 taken common, V2 square minus U2 square will be V2 minus U2 and V2 plus U2. Now to simplify it more, see, this will be equation 1. Take this as equation 1. Take this as equation 2. So what we shall do is we shall do equation 2 divided by equation 1 if we do. म्हणजे हे equation divided by this equation. This M1 will get cancelled. M2 will get cancelled. U1 minus V1 will get cancelled. V2 minus U2 will get cancelled. What will remain will U1 plus V1 will be equal to U2 plus V2. U1 plus V1 will be U2 plus V2. Let me remind you, we are doing perfectly elastic collision, head-on elastic collision. See, law of conservation of momentum is also conserved, we have taken, and kinetic energy is also conserved here. So this we shall simplify again. This U2 will take to left side. See. No. Then it will be U1 minus U2, or we can take U1 to this side. Let me have this pen. See, this U1, if I take to this side, it will be U2 minus U1 here, and V2, if I take to this side, it will be V1 minus V2. So the simplified thing is now U2 minus U1 is equal to V1 minus V2. If we remember the definition for a coefficient of restitution E, the formula is E is equal to V1 minus V2 upon U2 minus U1. See, V1 minus V2, here it is, upon U2 minus U1. Now what we observe is these two terms are equal. So coefficient of restitution is 1 for perfectly elastic collision. Or simply elastic collision. Now see, this is U2 minus U1 is equal to V1 minus V2. We shall write an expression for V2. So V2, if I take to this side, I shall have V1, when this comes to this side, plus U1 minus U2. This I have written here. This expression will take to next for the next, we'll use for the next point. So see, this, see now this I shall use here. V2 is equal to V1 plus V1 it is. So V1 plus U1 minus U2 plus U1 minus U2. This is the law of conservation of linear momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. And instead of V2, we have used this substitution, U1 plus V1 minus U2. So after simplifying this, we need to simplify. After simplification, we get V1 is equal to M1 minus M2 upon M1 plus M2 into U1 plus 2M2 upon M1 plus M2 into U2. हे फक्त या गोष्टीचं हे याच्यावर सबस्टिट्यूट केल्यावरचं सिम्प्लिफिकेशन आहे. तर what we have observed is V1 we can write in terms of U1 and U2. Initial velocities आहेत U1 आणि U2 आणि हे masses आहेत M1 M2. So initial velocity u1 u2 च्या टर्म्स मध्ये आपण v1 म्हणजे फायनल वेलोसिटी ऑफ फर्स्ट बॉडी लिहिले. देन सिमिलरली हे जसं आपण v2 साठीचं एक्सप्रेशन लिहिलंय v2 इज इक्वल टू तसं v1 साठी लिहिलं तसे म्हणजे इंटरचेंजिंग v1 विल बी इक्वल टू v2 मायनस u1 प्लस u2. आणि जर आपण हे इथे v2 साठी एक्सप्रेशन लिहिल्यामुळे v2 एलिमिनेट झाला होता आणि वी गॉट एक्सप्रेशन फॉर v1. तसं हे जर एक्सप्रेशन जे v2 साठी लिहिले ते v1 साठी लिहिलं आणि इथे सबस्टिट्यूट केलं आणि हेच एक्सप्रेशन v1 साठी लिहिलं आणि इथे सबस्टिट्यूट केलं तर v1 विल हियर वी विल हॅव v2. हे एक्सप्रेशन इथे सबस्टिट्यूट केलं तर we'll have expression in terms of v2. v1 will be eliminated and after simplifying we'll get this expression. v2 is equal to m2 minus m1 upon m1 plus m2 u2 plus 2m1 upon m1 plus m2 u1. म्हणजे this is final velocity v2 in terms of initial velocity u2 and u1. प्रत्येकाने हे आपलं आपलं वही पेन आणि पेपर लिहून सोडवायची गरज आहे. So then you get these expressions. So see, a final outcome is v1 म्हणजे final velocity is v1 and v2. We have written them in terms of initial velocities u1 and u2 and the masses of the bodies. We shall see the special case when m1 is equal to m2. See, if m1 is equal to m2, see what will happen. m1 is equal to m2, m1 minus m2 म्हणजे ही टर्म कॅन्सल होईल, त्याच्यामुळे हे 0 येईल. सो हे 0च येईल पूर्ण. सो v1 will be equal to u2 and v2 will be equal to u1. We shall interpret this. See, म्हणजे final velocity of first body is initial velocity of second body and final velocity of second body is initial velocity of first body. That is, thus there is simply exchange of velocities. Now, if the first body is very massive and the second body is at rest, see what will happen. This m1 minus m2 or m1 plus m2 will be simply 1 and this will be more or less 0. So v1 will be equal to u2 and v2 will be equal to 2u1. That is the massive striking body is practically unaffected and the smaller body, tiny body, it travels with double the speed of the massive striking body. Now, suppose the striking body, that is the first body, is very tiny, small, and the second body is at rest. Then what will happen? Then v1 will be equal to minus u1 and v2 will be equal to 0. That is, striking body will rebound and the massive body will remain unaffected. This students should write down, solve themselves cases and study. स्वतः पेन आणि पेपरवर पेनाने लिहून सॉल्व करून बघायच्या गोष्टी आहेत या. We shall now see what is loss in kinetic energy during a perfectly inelastic head-on collision. See, in perfectly inelastic collision, kinetic energy is not conserved, that we know. Though momentum is conserved, kinetic energy is not conserved. Now, for perfectly inelastic collision, two bodies move jointly after collision, right? Here we have got two bodies. with mass m1, m2, initial velocity is u1, u2. Later on, for perfectly inelastic collision, they are going to move after collision, we're going to move jointly together. So then after collision, the velocity will be v. So using law of conservation of linear momentum, we can write, see, this is momentum of first body m1 u1 plus momentum of second body is equal to momentum of the joint body which moves after collision, because it is perfectly inelastic collision. Using this, we can calculate the value of velocity after collision v. This m1 and m2 will go in the denominator. So v will be equal to m1 u1 plus m2 u2 upon m1 plus m2. So we shall now calculate loss in kinetic energy, which will actually calculate. It will be total initial kinetic energy minus total final kinetic energy. Initial kinetic energy of first body is half m1 u1 square. Second body is half m2 u2 square. And final kinetic energy will be of a body which is moving together, both bodies moving together. So half m1 plus m2 into v square. V is the final velocity of the joint body. Now see, we have actually calculated the value of v here. See, this value of v will substitute in this v. So see what we get. This we need to evaluate. One can do it using pen and paper or work on it. See, this m1, m2, it is squared. So 1 m1 and m2 and 1 m1 and m1 plus m2 will get cancelled. And if we calculate, we get it like this. m1, m2 upon m1 plus m2, u1 minus u2 bracket square. See, mass is always positive. So m1, m2 upon m1 plus m2 is positive. u1 minus u2 bracket square it is. So square is always positive. So what we get is the change in kinetic energy or loss in kinetic energy, what we have calculated is positive. Why there is a loss? Because the value is positive and it is total initial energy minus total final energy. Initial minus final is you are getting a positive value. That means initial energy is greater than final energy. Thus, there is a loss of kinetic energy during perfectly inelastic collision. Now we shall consider a case of non-head-on collision in 2 dimensions. Head-on collision म्हणजे बॉडीची समोरासमोर टक्कर. ती काय प्रत्येक वेळेला तशी होईल असं नाही. So head-on collision is basically a special case of collision, we have to say. And head-on collision मध्ये we'll consider 2 bodies again. ही बघा, ही छोटी body which is of mass m1. This is first body, a small body we can see. This is having mass m1. This is second body, a large body we can see, it is of mass m2. पहिल्या बॉडीचं mass m1 आहे, दुसऱ्या बॉडीचं mass m2 आहे. The first body is having initial velocity u1. Second body is having initial velocity u2. Now see, if we consider this as a line of impact, see, we can see this is the common tangent that we can see. After collision, the bodies are in this situation. Suppose for when they collide, they are in this situation. See, we can see this is a common tangent, and so this will be the line of impact. Let us consider this line of impact as x-axis and common tangent at y-axis. So we can see this is angle alpha 1. So initial velocity makes an angle alpha 1 with the line of contact. For my body M2, this angle is alpha 2. So after collision, the first body which is having mass m1 will travel with velocity v1 in this direction, and second body will travel with velocity v2 in this direction. We know that in this collision, momentum is going to be conserved, linear momentum is going to be conserved, and momentum is a vector quantity. So to apply law of conservation of linear momentum, we will resolve this initial velocities u1 and u2 into its components. Component along this line of impact and a component along say common tangent, or at present we can use this as our x-axis, line of impact as x-axis and common tangent as y-axis, and we can resolve u1 along x-axis and y-axis, we can say. So if we resolve this u1, this angle is c alpha 1, this is initial velocity u2 is making an angle alpha 2, final velocity is making an angle beta 1 with x-axis, and v2 is making angle beta 2 with x-axis. So this component, see, u1 cos alpha 1 will be along this, and perpendicular component will be u1 sin alpha 1. u2 cos alpha 2 will be along x-axis, u2 sin alpha 2 along y-axis. This I shall write down, and then we'll see. See, u1 cos alpha 1, see, this is u1 cos alpha 1 along x-axis, sin alpha, u1 sin alpha 1 is along y-axis, v1 cos beta 1 along x-axis, u2 cos alpha 2 along x-axis, and v2 cos beta 2 along x-axis. One can verify that all cos components of these velocities are along x-axis. म्हणजे angle तसे choose केलेत की x-axis शी होणारा angle alpha 1 आहे, x-axis शी होणारा angle beta 1 आहे. इथे पण तसंच आहे, alpha 2 आणि beta 2 are the angles made with x-axis. So सगळे cos components are along x-axis and y components are along y-axis. So here we have considered a special case of collision where there is no force along common tangent. I repeat, no force along common tangent. Force nahi, force is responsible for change in momentum. म्हणून y components आहेत, there is no change in the momentum of y components. आपण या momentumला resolve केलाय cos alpha sin alpha, म्हणजे u1 cos alpha 1 u1 sin alpha 1. इथे फक्त मी along x axis components दाखवलेत, y axis वरचे component इथे लिहून दाखवले नाहीयेत, पण ते सगळे sin components are along y axis that we have seen. आणि see how what we have done is we have chosen, or we are studying a special case of non-head-on co-head-on collision where there is no force along common tangent. Force नाही म्हणजे change in momentum नाही, म्हणजे there is no change in momentum of y components, or momentum along y axis will not change. So we shall now see the expressions. So we shall apply law of conservation of linear momentum along x-axis now. See, all cos components are along x-axis. So u1 cos alpha m1, momentum is mass into velocity. So m1 u1 cos alpha 1. So m1 u1 cos alpha 1 plus m2 u2 cos alpha 2, this one, is equal to m1 v1 cos beta 1 plus m2 v2 cos beta 2. And जसं आधी म्हटलंय तसं, there is no force. We have considered a special case where there is no force along common tangent. So there, though no force, so no change in momentum. म्हणून y axis वर y components आहेत momentumचे, there will be no change that we shall write now. You see, m1 u1 sin alpha 1 is equal to m1 v1 sin beta 1, and m2 u2 sin alpha 2 is equal to m2 v2 sin beta 2. y components तसेच राहणार आहेत, चेंज होणार नाहीये. ते मॅथमॅटिकल फॉर्म मध्ये लिहिले. Now we shall write formula for coefficient of restitution, which is E is equal to minus of v2 minus v1 upon u2 minus u1. इथे आपण या v2 v1 u2 u1 चे व्हॅल्यू सबस्टिट्यूट करणार आहे. And it has become very simple because only x axis वरचे components आपल्याला घ्यायचे आहेत, y components do not change. So see, it is written v2 cos beta 2 minus v1 cos beta 1 upon u2 cos alpha 2 minus u1 cos alpha 1. Minus sign जर consider केलं, then it simplifies as v2 cos beta 2 minus v1 cos beta 1 upon u1 cos alpha 1 minus u2 cos alpha 2.